Good morning, students. Welcome to chemistry class. Today we are going to start chapter number 4, Periodicity of Elements. In this chapter, we will learn the arrangement of different elements in the periodic table, and in the start we will study about the history of this classification and arrangement. We already know that what are elements. Element is a substance that is made entirely from one type of atom, and atoms are the fundamental units of matter. And elements are classified to study the matter easily. Now, what is the periodicity of elements? Periodicity is basically the repetition or reoccurrence of chemical and physical properties of different elements in a periodic table. History of classification of elements. In the early era of science, only few elements were known, but new elements were being discovered. Not all the elements have been discovered, so scientists were working with the only elements that were discovered at that time. And they were trying to group elements having similar properties. The basic goal was to group or classify the elements, not compounds or mixtures. Like hydrogen and carbon are the two elements, but water and carbon dioxide are the compounds. So in the groups or classification or arrangement, they were only considering the elements. And it was important to study the arrangement or the classification of the elements in order to study the physical and chemical properties of the elements simple and organized. The arrangement helps to understand how different elements form the compounds, and also the arrangement of the elements make it easier for the scientists to identify their periodicity. Previously, the classification was based on atomic mass of the elements because it was thought that properties of an element was based on its atomic mass. But recently, a complete classification has been made which is based on atomic number of the elements instead of their atomic masses. Ludwigs Classification. One of the initial attempts to classify elements was of Ludwigs. He noticed that of the three elements with very similar chemical behavior, that are calcium, strontium and barium, the atomic mass of the middle element, that is the strontium, is almost the arithmetic mean of the other two. He proposed the law of Triad or the rule of Triad. Triad means group of three. This law states that central atom of each set of triad had an atomic mass almost equal to the arithmetic mean of the atomic masses of other two elements. It means that the atomic mass of the second element is approximately equal to the average of atomic masses of first and third element. Here in this table, you can see the two groups of triad. Let's take the average of atomic mass of first element, lithium, and the third element, potassium. So we will get 39 plus 7 by 2. That will be 46 by 2, and that will be equal to 23. That is the mass of the middle element, sodium. The Dobrynin's classification wasn't so successful. There were some drawbacks that this law or rule cannot be extended to the classification of all the elements because it is true only in the cases of very few elements. Newlands Classification. In 1863, John Newland, a London industrial chemist, proposed Newlands Law of Octave in order to arrange or classify the elements. He states that if elements are arranged in the order of increasing atomic masses, the eighth element starting from a given one has similar properties as first one. That is, its properties are kind of repetition of the first, like the eighth note in an octave of music. For example, if sodium is the eighth element starting from lithium and has similar properties, magnesium is the eighth element from beryllium and has similar properties. Like you can see in the table that the first element is lithium, second is beryllium, third boron, fourth carbon, fifth nitrogen, sixth oxygen, seventh fluorine, and eighth is sodium. So the properties of the lithium and the sodium are approximately similar to each other, as sodium is the eighth element from the lithium. Similarly, beryllium is the first element for the magnesium that will be eighth of the beryllium element. So the properties of the beryllium and magnesium elements will be similar. Law of octave for the first time brought to the light the existence of periodicity of elements. Now what is periodicity? Periodicity is the repetition of similar properties after a regular interval. So it provided a great idea towards the development of modern periodic table. This law only failed because it held good for the first 16 elements, but it did not work after 17th element, and hydrogen was not included in this sequence. Ludwigs Classification. Another German scientist, Ludwig, arranged 56 discovered elements in his periodic table. He described a relationship between atomic masses and atomic volumes. Ludwig calculated the atomic volumes of elements. The atomic volume of an element is the volume which would be occupied by 1 gram atomic weight of atoms of elements if it were a solid. In order to emphasize the concept of periodicity, he plotted a graph between atomic volumes of elements against their increasing atomic masses. His law stated that the arrangement of elements is the periodicity of their atomic volume and atomic masses. So here is a graphical representation of the Ludwig's law, in which the curve obtained consists of sharp peaks and broad minima. He observed that the elements with similar properties occupied similar positions on the curve, and the regular spacing of the highest points confirms the idea of periodicity that was suggested by Newland. For example, the highly reactive alkali metals lithium, sodium, potassium, rubidium and cesium occupy the peaks, showing that these elements have largest atomic masses. Similarly, the alkali earth metals like magnesium, calcium, beryllium, strontium and barium are occupying the descending position of the curve, showing that they have less atomic volumes than the alkali metals, which are highly reactive and they react with water to form hydrogen gas. So this was all about the early developmental stages of the arrangement of elements. In the next classes, we will study about the Mendeleev's classification, about the modern periodic table in which the elements are arranged in groups and periods in such a good way that we can understand most of their electronic configuration and their chemical properties. So I hope you all have understood well, and please don't forget to study from your textbook and solve the related questions. Thank you so much.